Hello everyone, for this tutorial video, I would like to explain how to figure out the derivatives of the inverse trig functions, as opposed to the normal ones we figured out earlier. If we know function of x equals sine of x, then we know its inverse, g of x, equals inverse sine of x. And we know the derivative of inverse function is 1 over the derivative of the function it is inverse of. We know the derivative of sine is cosine. We plug this in. We have 1 over cosine of inverse sine of x. We can condense the argument of cosine inverse sine as simply y. We know that cosine squared of y plus sine squared of y equals 1. So cosine of y by itself must be the square root of 1 minus sine squared of y by algebra. We substitute this in the denominator of the derivative. We know that sine of y is x. So we plug this in, we have 1 minus x squared square root of all of that. In conclusion, the derivative of inverse sine is 1 over the square root of 1 minus x squared. We do the same general process for the inverse cosine. So in this case, the derivative in the denominator is negative 1 times sine, and the argument or input is inverse cosine of x. We factor the negative 1 out from the sine. See that inverse cosine of x equals y. Remember the trig identity with the Pythagorean theorem. See that sine of y must be the square root of 1 minus cosine squared of y. Remember that cosine of y equals x. In conclusion, inverse cosine is 1 over the square root of 1 minus x squared times negative 1. We derive inverse tangent by plugging in the inverse derivative formula, so it becomes 1 over secant squared of inverse tangent. We substitute in y for inverse tangent of x. We start with the Pythagorean identity and get things in terms of tangent. By dividing everything by cosine, we get 1 plus tangent squared of y equals secant squared of y. So the denominator is now rewritten as 1 plus tangent squared of y. We know tangent of y is x. We plug this in. The final answer for inverse tangent is 1 over 1 plus x squared. We prove inverse cotangent with a similar process, and we should get negative 1 over 1 plus x squared. Lastly, the derivative of inverse secant is 1 over absolute value of x times the square root of x squared minus 1, and the derivative of inverse cosecant is negative this. Now that we have figured out more simpler rules / formulas for the derivatives of different types of functions, we can figure out the derivative of function compositions, which is called the chain rule, as a reference to a composition being a chain of functions. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.